For those that don't know, I have a doctorate in atmospheric physics, and I still remember the moment when I decided that physics was the way to go. I was about 15 years old and pretty cool. And I really expect you to remember the 1 + 1. Okay, who did that? That was Jeff's Adam. No one likes a tattletale. Yup, pretty cool. But it was around this time that I learned about something that would genuinely change my life. On the other hand, the sun is powered by nuclear fusion. If we could get that to work on Earth, we would have a virtually limitless source of power. Whoa. Wow is correct, Adam, but try to be cool about it, yeah?
Fusion is, in fact, deeply impractical.
Okay, who said that? Learning about nuclear fusion was genuinely a big factor in me deciding to study physics at university. I mean, a single source of energy that could provide power for the entire world? Yes, please. So fission, which powers nuclear power plants today, works by breaking up heavier elements into smaller parts. But fusion, on the other hand, works by taking light elements like hydrogen and squishing them together to form heavier elements like helium. Since the fuel just comes from water, and since there isn't really radioactive waste in the same way as for fission, this could provide clean energy for humanity. That is, if we can actually pull it off. Nuclear fusion is still being worked on today. But when I went to university, I was actually taught by a fusion physicist. In fact, she took us on a trip to the Joint European Torus, or JET, one of the biggest nuclear fusion reactors. So here we are, one of the most high-tech facilities in the entire world. I mean, it looks a lot like my apartment. Well, maybe if you had a green screen, it wouldn't. Anyway, if you take a look at the screen over there, you can see the reaction in process. That is awesome.
No, it isn't.
What is that ghost's problem? Seeing this reactor up close and personal led me to a pretty fundamental question. When will fusion actually be ready to provide electricity? Oh, in about 30 years. The answer to this question never seems to change. Whether you ask it in the 80s or the noughties, or even if you ask it today, fusion power always seems like it's another 30 years away. Fusion is just really, really hard. For a reactor like JET, you have to heat the plasma hotter than the center of the sun. Keeping that under control has been compared to suspending a jelly using rubber bands, which is something I can confirm would take me at least 30 years to perfect. But still, once we do master the source of the sun's energy here on Earth, that would mean virtually limitless green energy for the entire planet.
No, it really wouldn't.
Okay, what do you want? You've basically haunted me my entire life, although weirdly, only really when I've been talking about nuclear fusion.
I'm not a ghost. I'm Charlie from Our Changing Climate.
Oh, Charlie from the Our Changing Climate YouTube channel. The channel isn't just Charlie's voice though, it's also incredible motion graphics.
Oh, it's nothing on yours.
Oh, shucks.
But even if we can make fusion work, it's not going to solve climate change.
What part of virtually limitless green energy don't you understand?
Look, I get the appeal. There's a reason this is a staple of science fiction. Harnessing the power of the sun makes us feel godlike. Our fusion cravings aren't much more than divine vanity.
Says the all-knowing, disembodied voice.
But divine or not, with fusion, timing is everything. Solving climate change means getting to net zero CO2 emissions globally. For our most ambitious targets, we need to do that in around 30 years.
Oh, right, yeah, that number does sound familiar.
We need a climate escape plan now. If you're clinging onto a ledge for dear life, you don't want to be waiting around hoping someone invents a high-tech teleportation system in a couple of years. You just want someone to throw you a rope.
Okay, point taken. But what if there's a breakthrough and fusion is actually working pretty soon?
But just because something physically works doesn't mean it works economically. If we're going to rebuild the world's current infrastructure, we need something affordable. And fusion would not be cheap. Just think of all the superconductors and supervision it requires. It's all well and good if we've got that teleportation system, but if you can't afford it, you're still gonna take a nasty fall.
So if fusion is just too expensive and too futuristic, are you saying we're just stuck on fossil fuels?
Not at all. We can already harness the sun through solar power, and solar technology alongside wind is already cheaper than burning fossil fuels for many parts of the world. So pushing forward with these readily available technologies will allow us to decarbonize as quickly as possible.
Okay, I hear you, disembodied voice, but if we're going to solve climate change, we need to decarbonize completely.
Yes, completely and as quickly as possible.
But doing anything 100% is difficult. I mean, I love renewables, but if we're going to kick our fossil fuel habit, then we need as many tools as we can get.
Sure, like large-scale storage and smart grids.
So isn't it important that we keep researching technologies like nuclear fusion? It could end up being a handy piece of the decarbonization puzzle, even if it is a few decades down the line.
Okay, fine. I'll accept that researching technology like fusion is still important, but only if you accept that fusion isn't some get-out-of-jail-free card. We need to start using the tools we already have to start cutting emissions now.
Okay, deal. But can I ask you one more thing?
Which is?
Can you stop haunting me?
Or what? You're gonna tell on me?
No.
Didn't think so.
Fusion is just one of the ideas that capture our imaginations and give us the impression of a quick fix to climate change.
Which raises the question, why do we fall for these silver bullet ideas in the first place? So we made a video over on my channel aiming to answer that question.
If you haven't already, make sure to subscribe to Our Changing Climate for awesome in-depth looks at how our lives intersect with the environment. Okay, until next time.
Bye.